Okay. Yeah. Today we are going to go through all the protocol layer code and the protocol architecture. So from architecture layer, we are going to give some big picture of what we are doing uh, with the protocol on a high level components. So what kind of protocol is doing here is we want to allow people can register IP into a protocol, and we use the IP NFT as a kind of ownership identity, and also people can use IMT to register an IP asset. IP asset is kind of a contract we deploy on a protocol and represent the IP for user can use that to this IP asset to do the uh, everything around the IP, for example, licensing or royalty or dispute or something. So we have IP set first, then we have a, IP registry. Registry play kind of a, storage or state. It maintains a global state of the IP related things. I will go into later. And with that registry, we also have a license template. License template, because of when we are working with IP, we need a define license. Say this IP, the who can you can do what kind of things on this IP, and what kind of royalty or a mini fee. That mini fee you have to pay to the original IP owner. Yeah, this kind of thing. They use this kind of license to define what kind of right you have this IP, and also we have a with a template you have a list of license terms, and the IP owner can select to what kind of terms, what kind of uh, terms the derivative or kind of license token holder can have. For example, whether they can transfer their license to others, or whether they can make a derivative on their a further derivative on their work, and so forth. And another major component is called asset controller. Asset controller is we define how it's between these modules. Say this IP can can dedicate their something function to another user or another contract. So that contract can call another modules on behalf of this IP. So basically, as controller is define who can do what on which IP. And we also have a kind of two tokens. This one is a lesson token. It's a MT token, and also we have a royalty token. It's a ERC20 token. And we lesson token is used for lesson module to create so that you can hold this lesson token. Then you have a hold the lessons for IP. And royalty token means a kind of royalty module going to create this royalty token and represent what kind of proportion you hold for the royalty revenue when this IP get any royalty income. Okay, and just this side, we have this registry, we have an IP set, and we have a bunch of list of modules. So basically, in our protocol design philosophy, we think this IP set is a play kind of a nouns, and the module plays a kind of a verb. That means IP set hold all the kind of state and the data of around the IP, and the modules hold a kind of logic you can doing with this IP, so that with the IP asset data here, and they can have a list of modules, means a list of functions, for example, license module, so that IP can have all the license operation based on this IP asset. And we have through the royalty module, we can do the royalty related operation and stuff with the IP asset. So basically, each module can extend functionality and features adding to this IP asset. So that with this kind of architecture, we can have I keep adding new functionality to the IP by adding new modules. And each module can also have their own kind of strategy or policy. For example, royalties for currently module can we support to our native policy, one called RAP and RRP. So the IP owner can customize which kind of policy they want to apply to their IP when we handle the royalty. Yeah, basically this is our high-level architecture. And we zooming into the IP side itself. IP side is kind of a IMT plus IP account. So in our protocol, we use IPT to represent the ownership of this IP. So this means when you register an IP into protocol, you have to IPT first. Then you use the IPT to register IP into protocol. Our protocol going to deploy an IP account for your IP. It's a IP account is a ERC 651 account, and it's basically it's a contract and deploy on our protocol, so that when you own this account is bound to this IMT. So that means when you own this IMT, means you own this IP account. So as an IP account have a kind of some function like execute, allow this IP account can execute other modules. And when we do the execute on this IP account, they're going to check whether this a caller, that means message sender, is a NFT owner. If it is a owner, they can execute this function on the IP account. But if it is not owner, they cannot. So basically, VMT represent the ownership of this IP account. So when you transfer your IP ownership to others, that means you transfer all the IP kind of right to others. In that case, you have no authority to run IP account to execute IP account anymore. And the new owner of MT going to can execute that IP account, right? So yeah, so in a protocol, everything is around the IP. So for example, if we say the licensing, royalty, this kind of stuff, everything is around IP. So yeah. And the registry, as mentioned, so in the protocol, hierarchy and this registry is kind of play a central global global state storage for all the kind of IPs. For example, we have a licensing registry and IP registry. It's not like the IP asset itself. IP account itself only hold the IP related, this specific IP related information, while the registry they're going to hold a kind of global state of the whole protocol. For example, IP asset registry they're going to hold all the kind of IP asset registered into our into protocol, and the licensing registry holds all the license state of the across the whole protocol, and the modules registry we hold the kind of all the modules can whitelist in our protocol. Yeah, this is we use a registry to hold all the global state across the protocol. So going to each major component for IP asset registry, it's very simple. It's just it's permissionless. Permissionless is everyone can register their any IoT to protocol as a IP, so that for example, you hold a kind of PYC MT, you hold you just use this BMT MT, and you have MT contract address, you have a MT token ID, and you pass this information to the protocol, and protocol can register deploy IP account for based on the ERC 601 standard and for bound to this FT, and then you have a IP account deploy for you on protocol, and you can use FT to control this this IP account. Yeah. Module registry. Module registry is for represent who is whitelist. Which module is whitelist can interact with IP account in our protocol. So basically, they register a kind of a name of this module and the address of this module. And for currently, only our core module is registered when we release mainnet. But in the future, they support others. Community member can develop their own module, and they can and once we see this module is audited, we can add it to our protocol so that IP account can use their module. Licensing register directory is kind of a they hold all the kind of state of license in the protocol. For example, they hold all the license template registered to our protocol, and also they hold all the mappings between the license config of a IP and on which license, so that IP owner can configure like meeting fee, license hooks, something else. So this basically they hold the mapping for global protocol to from license config and the license and for each IP, and also there's a hold kind of which IP have a which attached to which license with some kind of mapping, and also they also hold the kind of this IP kind of IP graph. So this IP have a which derivative, and this IP have which parents of this IP, and also they essentially have functions to do some validation when you register derivative or mint license token. They're going to validate whether this registered derivative is valid or not. For license template is kind of define a legal framework of license terms, so that allow IP owner can define their own, can tailor their own license terms based on their need. For example, they can use a template. They can define a license, allow others to remix their IP, but not for commercial or for commercial. They can use that to define this kind of license terms based on a license template. So currently, our license system is under this structure. So in the middle is a license module. A license module can generate license token for each for any license, so that this IP owner can or others can mint license token, so that they can use this license. They can use license for something. For example, if you hold a license token for a BSC, and BSC this token also is for commercial use, then you can make marks or t-shirt based on this BSC NFT. And also, this modules is also have associated with a license template, and different template can have a different license terms. Currently, we only have a PO license template with our out-of-box provided. The PO is means a programmable IP license, and in the future we can allow others to register a different license template into our protocol. And also, when IP owner attach a license to their IP, they can also define license hooks associated with this license. And with hooks, they can do some customized operation. Hooks we allow the kind of a third party or custom or community member can develop hooks into our protocol so that they can customize the license. For example, they can define total supply limitation, total supply of license token when they mint license token, or they can use kind of create some bounding curve minting fee for this token for when minting license token. Yeah, and one is all the license registry going to hold all the kind of license data state when we going to find when we execute the license module. So in license module, they only hold the logic, and all the state is held in the registry. Yeah, so the modules, we kind of currently we support a list of modules for now, and the modules kind of just mentioned before this define the actions we can do on IP, so that this action eventually going to change the state and the data around the IPs, and each modules have a defined as different logic based on the policy. As an example, for royalty module, we have a RIP and a RRP policy, and for DBuild we have a different attribution policy, and for this not least here we have a grouping module. They have a different grouping pool. This considered is another kind of a policy we can define with a grouping module. So a quick overview of our typical modules. The first one is a royalty module. Royalty module is define how handle the royalty between IP and also between how this when this IP have any royalty revenue income, how this income can distribute to their own royalty token holders. Basically, with the royalty module, and they can define this kind of each this IP going to pay 0.5% to this IP IPS3. IPS3, because they derivative from the IPS2, they're going to pay 10% revenue royalty to this IPS2, and so forth. Because IPS2 is a derivative from IPS1, they have to pay 5% to IPS1, and so eventually we can see IPS3 going to have to pay the royalty to both IPS2 and IPS1. So add up, so they pay the total 15% of their income to these ancestors IPs. Yeah, basically, royalty module going to define how this royalty be distributed to based on IP graph and from the children IP to the parents IP. And the dispute module is using to when you use this IP, there's IP, but the IP maybe is a kind of just a duplication, or it's illegal. In that case, we allow the users to raise a dispute against any IPs, and we define like kind of a dispute policy and for each IPs. Yeah, we can have more details when we look at the code. Another is we call asset controller. So asset controller is manage all access for IP accounts, and if the IP owner want to allow other ones can to delegate some kind of actions or to take action on behalf of this IP owner, they can use asset controller to set a permission to others account or UA account, so that the other user can take action on behalf of this IP owner to call modules and change the state of this IP account. And we have, just mentioned, we have two tradable tokens. It's a license token and a royalty token. So license token is represent the license right. So who owns this license token? They hold this license right for an IP. So each IP can have attach multiple license, and each license can mint their own license token. So the other users can hold the token, or IP, as RIP can hold the token to either register derivative of this IP based on the license token, or they can just hold a token to do some commercial use for something else. So when you use a license token to register IP, the license token going to be burnt after this IP be registered as a derivative. And yeah, the royalty token, you can use that to represent, to claim the royalty revenue income when this royalty, when this IP have any revenue income. And this token also can be tradable and be transferred, and so that you can transfer your own royalty token to others, so others can have this revenue income from this IP. Yeah. Okay, this is just a callback. This is a whole architecture picture we just discussed earlier. And just a quick go through what kind of typical workflow we're going to have this involved protocol. So the first thing is you need a register IP. In this when you register IP, you basically need a 3 steps. So first step, you're going to have to acquire IFT. You have the IMT first. Then with IMT information, you call IP as a registry to register IP, IMT as an IP, and then you can set some metadata of this IP. And maintenance token process, basically, you have IP account first, and then you call license module to attach a license terms. For example, you can attach a kind of a non-commercial remix kind of license to this IP, and the other one then can mint that token from this IP. And or if you are IP owner, you can just mint a private license to anyone. That means you don't have to attach a license to this IP. You can directly mint a license token for any license to anyone. Register derivative IP. So once you hold a license token, you can make your own IP to register a derivative of another IP. For example, the process will be like you register your own IP and you acquire some license token, then you register the derivative IP with the tokens. Then the tokens are going to burn. Yeah, basically this is a kind of a high level and the typical workflow work with our IP. Just a quick pause here. You can ask any questions. Okay. If no question, we can go to look at our code. Yeah. So this is our code in this repo. We call our protocol called core v1. So on the directory here, we can see all the contract is in a contract directory, and there's a guide to if you wanna deploy your own protocol for testing or do some POC, you can follow this POC this kind of deployment guide to deploy a protocol to our layer 1 chain. So you can here you can put a kind of a seed number here. So because you don't wanna complete with others their deployments. So you can use give a different seed here, a seed here, and you can deploy your own protocol on different address, so that you can avoid conflict with others protocol deployment. Okay. For the contract, the first directory is called access. In access directory, we have a access controller. We just talking about in our slides, and also we have a IP graph ACL. So IP graph access control list, access control list is used to control which module can access our precompiled IP graph. So programmable IP graph is we built in our UVM. I think yesterday he also mentioned the IP graph. So basically we create the IP graph in our UVM, and with so that we can build in our IP graph structure into UVM directly as a precompile contract. So basically have a list of functions allow to interact with the IP graph. For example, they can add IP into the IP graph by call add parent IP, and also they can set the royalty between two IPs, and also they can have a kind of a list of query functions. You can query the IP graph state. For example, how many IP account, how many parents, how many ancestors this IP have, and or how many, what kind of royalty between need to pay between the two IPs. Yeah, these kind of things we use built-in precompiled IP graph to handle. Yeah, so but this ACL is using when we change the state of the graph, they have to only whitelist the module can change the state of the graph. So we can see here it's a ACL address. It's just address of the ACL contract deployment on this address, so that one module want to access IP graph, they're going to call allow function, so that allow this IP graph is can be allowed to be changed. The state can be changed. Once they finish the work, they call disallow. They make the IP graph read only. This tool, this others control is just convenience. Contract for modules can define kind of modifier here. Module can use to apply some access control based on their needs. And interface directory is list all interface in under this directory. And yeah, all invitation of modules is under the module directory. That's we mentioned. We have a dispute module, a grouping module, lesson module, and a royalty module, and also have a metadata module. So these are all the modules implementation on the module directory. And as also mentioned before, the directory. So all the directory is under the directory registry directory. Sorry, registry directory. So for example, we have a license registry for license global state, and a module registry for registered module into protocol, and IPS side registry basically is inherited from both IP account registry and the global IPS registry, so that with the IP side, you can deploy IP account. Also, you can register grouping IPS side within our protocol. And this group IMT used to register the group IPS side, and this is our IP account implementation here, so that when we register an IP, they're going to clone from this IP account and follow the ERC 601 standard, and they're going to deploy this cloned IP account on the chain, and so that you have one mapping between the MT and the IP account or contract. Yeah, this IP account storage and this assessment token. Yeah, basically the high level of our directory and introduction of protocol. Yeah. Yeah. Yeah, we can answer some question. What proportion of the code base field is the most vulnerable? Uh, uh, I think I do say not vulnerable, but I do say the most critical is I think so around the kind of with money things most critical. We wanna most take care of around the kind of license meeting fee or kind of royalty. I think everything around the tokens and the money is I think we most wanna be secure.
Yeah, I would say the IP accounts are also like a critical part of the system.
Mm.
And as Tinter said, like royalty tokens, licensing tokens, that will be the interaction with the IP graph, which is part of an execution layer that communicates with the proof of creativity, is also very important. I don't know if we have much vulnerabilities left there, but it is an important interaction.
Yes. Yes, I agree. Yeah.
Disputes have also, since like the ruling of a dispute, it has economic implications because it will like ban a certain IP account for doing things. I guess that could be something to be studied. Like people cannot bypass ruling of the dispute system, stuff like that.
Oh, okay. If no further question, yeah, I think maybe we can close here.